If there's one thing I've learned in my 50 years of woodworking, it's that mistakes happen. Yeah, all the time. Matter of fact, I don't think I can say that I've ever made a project that I didn't make a mistake on. That's led me to the philosophy that a really great woodworker isn't somebody that doesn't make mistakes. It's somebody that's good at salvaging their mistakes. You know, yeah, you're going to make mistakes. And they're going to stand out to you, and you're going to want to point them out to everyone. Don't do it. Don't do it. They probably won't see them anyway. They may think it's supposed to be that way. But you know it's there. Okay, so what are you going to do about it? Well, here's a project that I made, and I got all done, and it actually went really well. There weren't a whole lot of mistakes in there. But when I got done, it turned out the whole project was a mistake because it couldn't be used the way it was intended. So here's that project. And here's what I did to salvage it, repurposing that project into something else. All right, let's take a look at this plan for the step stool that we're going to make. And as usual, we have our 3D view here, or isometric view, showing that we're making a two-step stool. And they finished it a couple different ways just to give us an idea what that's going to look like. The important parts of this are the parts that are more hidden, and that's the brace work that's underneath. We get a better look at that on the exploded view here. So we've got an upper and a lower tread. Here's the upper and here's the lower. The side pieces, and you see we've got these pieces here. These are the tread supports. So one will be attached here and the other there, and that's what attaches the top and the side together. And then back here, this is really important, this brace here. Now, I'll talk more about that in just a moment, why that's so important, okay? And here's our dimensions. We find out that's 24 inches wide by 21.5 inches deep. Now, this is kind of interesting. This is very typical for steps. Each step is 11 inches long. If you add that together, that's 22 inches. But we've got 21.5 inches of depth. And that's because you see this overhang right here? There's usually, with a step, there's an overhang. And it's somewhere between a ½ inch and an inch, depending on how it's designed. The other thing we can see looking at this drawing, is that there are pocket holes here. We're going to be using pocket hole screws for assembly. At least for putting that brace piece in. So that's important. Here's our details. They did give us dimensions for drilling our upper and lower supports. This is the long ones. These are the lower ones. This is the upper ones. And we're going to be putting a lot of holes in here, obviously. And the dimensions are important because we don't want to run the screws through, in both directions in the same spot, right? This is looking up from underneath, and we can see how those supports are installed. And then here we've got our instructions. And the important thing we see here is in our material list, pretty much everything is 5.5 inches wide. So we're using 2x6. It's 5.5 wide by 1.5 thick. So we're using 2x6 materials for most of this. It's going to be a really strong step. Except for those supports, those tread supports, which are 1.5 by 1.5 or 2x2s, okay? So we need a total, I've added this up, we need a total of 4 2x6s, 8 feet long. We'll end up with a little bit left over, but that's typical. And 1 2x2 that is 8 feet long. And then here again, we see their verification, pocket hole joinery. We see the verification that, yes, in fact, we're going to be using pocket holes to put this together. Now, I mentioned about that brace, and here's what I want to show you, okay? I'm going to do a little physics with some drinking straws here. This is a cube, okay? And I've just connected together with chains of paper clips here. But if you notice, it doesn't stand up real well. It's kind of wobbly, all right? Now, if that structure, on the other hand, was made of triangles like this, it's very strong. You see, it's the diagonal braces that make it strong. If we want to make this strong, we need to put diagonal braces on the sides, okay, going in opposite directions. If you ever look at a bridge, you'll always have diagonal pieces. You'll have triangles in the truss work for the bridge. It's always done that way because that's where your real strength comes from. You also find it on houses, but it's not as obvious because a lot of times to come up with that angle, what they do is instead of putting a diagonal brace here, they might actually use a piece of plywood. Well, that piece of plywood is going to give us diagonal brace in both directions at the same time. So we're going to still going to get our strength from there, okay? And that's what's going to keep it from collapsing. So when I was talking about that back brace being important, that's what's doing that for this step stool. So that's what we want to be looking at, is making sure we've got that strength in there And if we go back to our original drawing, and we look here on the back, and here's that brace, and that's really what's providing the strength from keeping our step stool from doing that. Okay. Now, granted, the rest of it supports the weight, but this keeps it all in alignment. So I've got my 2x2 here for the supports, and I need a total, I need 2 pieces that are 21 inches long and 2 that are 9. So that's not going to use the whole material, which is good because I've got some knot holes in here and I need to cut around those, okay? So as I cut this, I'm going to be trying to avoid using that part of the material. Cutting these 2x6s on the radial arm saw can be really tricky because what happens is that the material, the saw blade wants to pull itself through the material and it'll bog down. And normally it would trip the circuit breaker, okay? So I've got to be very careful cutting this, and I actually have to put back pressure on the blade. Now, a miter saw won't do that, okay? But some saws will end up trying to pull their way through the material, and that's something to watch out for. The other thing you want to be careful about is you don't want material hanging out in the air. And it doesn't matter if you're talking about a radial arm saw or a miter saw, this is a risk. What I've done here is, since my table saw is so close to my miter saw, I've got my table saw sitting here with a 2x4 on it, and that 2x4 is just the right height, so my material's laying flat across the 2x4 and onto the table of the miter, of the radial arm saw. So that works out really great for me. We've got to drill a lot of holes in the stringers or the supports for the steps on this project. And one of the challenges that we run into working with drills is holding them perpendicular to the surface, you know, and getting a hole that's absolutely perpendicular to the surface. They tend to tip one way or the other, and there's really no good reference on the drill to really make sure that you're absolutely perfect. I've always thought, you know, drills should have a bubble level in them or something, maybe here on the back or something to allow you to do that. But it doesn't work that way, okay? So what do? Well, what I usually do is I drill my holes on the drill press, and that makes sure it's perpendicular. Well, that's great if you got a drill press, but if you don't, then what? All right, well, here's a couple options. All right. Number one is a device like this, and this is an adapter, and you attach your drill to it, and then you put your drill bit in the chuck, and this allows you to maintain that perpendicularity. Now, really on this piece of wood, that wouldn't work too well because the piece of wood is only 1.5 inches wide. When I drilled the holes in my bench top, that's what I use so I can maintain those perpendicular. But it's really not ideal for a piece of wood this narrow. So here's another option for you that's easy to do and works really well with pretty much any size piece of wood. Okay, doesn't work with spade bits, but any twist drill or brad point bit. And that's just to take a couple pieces of scrap. This is 1 inch square scrap, and make an L. And it doesn't even have to be perfect. It doesn't have to be what you're concerned about is the perpendicularity between this surface and this surface. Okay, not whether or not you have a perfect right angle. And we want 2 surfaces so that we make sure we're perpendicular in both directions. Let me just set this on our piece of wood, line up our drill bit, and then make sure the drill bit is in contact with both of those surfaces. And as long as it is, when we drill that hole, it's going to end up absolutely perfect. Now, what if I got to drill the hole deeper and this gets in the way? Well, once I'm in, say, 1/2 inch or 3/4 of an inch, that drill bit's going to stay going straight. And I can go all the way down, and I've got a perfectly perpendicular hole, quick and easy. This step stool has a brace across the back that's there to keep it from racking. And it's installed with pocket screws. Now, if you look at the design of the step stool overall, you'll notice that none of the screws are visible. Everything's attached from underneath. So if we use regular screws, say through the top of the step into the brace, that would be visible, okay? The other problem is that for the ends of this brace, if we run screws through the side pieces into these ends, well, we're going into end grain, and that end grain, or that screw going end grain, is actually going to cut the wood fibers, and it's going to be a weak joint, and eventually it'll fail. So what we want to do is we want something that we're going through long grain into long grain, and the pocket hole gives us that capability. So there's two really good reasons to use pocket holes for this. Now, I did a much more thorough talk about the pocket holes and pocket hole jigs in the video on building the clamp rack. So if you want to see something more detailed about it, that's the place to go. But a couple things we need to do with the clamp rack. One is that we have to adjust our drill bit, the stop on the drill bit for the thicker wood. Now, the whole system, the pocket hole system, is very dependent on the thickness of the wood we're using. When I did it before for the clamp rack, I was using 3/4 inch thick material. Now I'm working with 1.5 inch thick, or 2x8, right? And so we move this stop from the 3/4 inch position to the 1.5 inch position, which is marked right on the drill. And we can go ahead and chuck that up in our drill motor, and that's ready to go. But we also have to change it here on the jig. Now, different jigs will change in different ways. This one's really easy. It's just 2 buttons here. Put them in, and we set this up to, there it is right there, the 1.5 inch thick. It's marked on the side of the gauge. It's actually marked on both sides, okay? So it's ready to go now. Now we can put our wood in here. It's a little tight fit. Line up with the hole. Tighten the jig up so nothing's going to move, and drill our hole. So that gives the hole for an angled screw to go through this piece and into the other one. So the angled hole is needed for this, but there's actually no pilot hole or anything in the other piece. The screw itself will go right into there. Okay, so we're ready to put our step together, and according to the plans, we put the sides together and then put the treads on. So I'm going to go ahead and follow that. I've got my pieces lined up here, and I'm using a framing square just to make the bottom straight here, okay? And with that in place and those lined up, I'm going to go ahead and put 1 bar clamp on here just to hold things together. This is just to help hold it in alignment while I screw it together. Okay, now for this top piece up here, I've got to remember that I've got my support going back here, the brace, and so I'm going to go ahead and use this same piece of wood to draw myself a line, and I know I've got to keep this in front of that line. And then here, for this coming across, well, I'm lining up here, but to get that same alignment back here, I'm just going to take another one of the pieces and draw myself a mark there, okay? Now, they tell us to use glue, and that's a good idea, so I'm going to go ahead and put glue on here. You don't need to smooth the glue out all the way across the surface like you would if you were, say, edge gluing panels. Basically, the idea here is the glue is going to help hold it together. But I also have a lot of screws here holding it together. So there's a lot holding this step together. Aligning it up. Now, you notice I've gone ahead and started my screws in there, and that's just to make it easier to work with. So there's 2 ways I can put this together, 2 tools I can use to assemble this. One is a drill driver, and the other is an impact driver. Now, the drill driver will work. The problem you might have with a drill driver is you just run out of friction, okay? So what I've done or friction stops you from moving, I should say. So what I've done to alleviate that is I took my screws and just dip them into some dish soap before I start them in. The dish soap acts as a lubricant, helping those screws to go in, and then once it dries, it actually helps hold them in place. So I'm not going to use a drill driver. I'm going to use a impact driver just because it's going to go in easier. You know, you can use either tool. Okay, this is something to watch out for. I've got a little bit of a gap right here, okay? Somehow this screw, because it's more of a gap here than is there, that screw didn't enter into the second piece of wood properly. So I'm going to back off those two screws, make sure I'm down all the way, and I'm going to run it back in again. Now you can see there's no gap there, okay? For this one, again, I got to line up with that mark I made back here. And I'm going to go ahead and use my dish soap. I basically use dish soap anytime I'm working with screws that are 2.5 inches or longer. Yeah, it's being ornery. Even though pine is a pretty soft wood, it's both categorized as a soft wood and it is soft as a wood. It's not real dense. You can run into spots that are pretty dense and pretty hard to work with. Like I just did with that screw that didn't want to go in. Okay, now I'll make the other one. Before we go on with our assembly, I just want to show you something here. This is one of the sides, okay? And because we're working with dimensional lumber, it's not real uncommon to run into wood that's got wane, you know, the edge of the log type thing, okay? So what I've done is I've put all the wane to the inside of this side. If you look at the outside, everything's nice and clean. Yeah, I've got a knot hole there, but I don't have any of that torn up look that the wane gives us on this side, okay? So the next thing we're supposed to do is put the brace on, the back brace. So I'm going to set that in place here. And I want to make sure I install it absolutely perpendicular. So I'm going to go ahead and clamp one of my squares here. These are some homemade squares. I have a number of them, and I use them for things like this, just for aligning things as I'm assembling them. And I've gone ahead and put my piece in backwards. There we go. The holes for the pocket square have to be on the inside, not the outside. So I've got two pockets here going down into this board, and we've got another two that are going to go up that way, all right? You use special screws. They're also 2.5-inch screws, but they're slightly different than the screws, the regular screws. They're designed specifically for use with the pocket hole system. And they provide you with a long driver bit to go with that. I want to make sure I'm lined up perfectly before I put the screw in. All right, now I can't very well do the same thing for the other side. I'm going to have to lay it on its back on the workbench so I can attach this other side. But I'm still concerned about being square, so I'm going to get my framing square back out here. Make sure my two sides line up square. Okay, so we're ready to put our step treads on. I'm going ahead and put the lower on first just because I've got this support piece down here, the brace down here, okay? And the treads, the instructions tell us to go ahead and stain them first, so I've done that. And we also see in dimensions that it's a 1/2 inch longer than the step is wide. So we're going to end up with it's 1 inch longer. So we're going to end up with a 1/2 inch hanging over each side. And this is just a piece of 1/2 inch material I'm using as a spacer. I could do it with a ruler too, but this is just easier, okay? So I need some glue on both ends. And we'll go ahead and set this in place using my spacer to make sure I've got it aligned properly, okay? And then I need to run some screws in from the bottom side here. Again, using my dish soap to give myself that lubrication. And the other one sits on top. Now, let me show you something here. I'm going to switch this over to this other side. Now, there's a possibility of this going in and out, okay? So what I'm going to use my same spacer on this side to make sure I've got the same 1/2 inch overhang that I have on the other side, okay? That's how I'm going to make sure I'm going to keep it square. All right, I could use a square, I could set up. That's the fastest and easiest way to do it. Again, putting my dish soap on my screws. Okay, I know I've got this lined up, right? And we can go ahead and screw it together. So here's the finished step stool. And as you can see, this part of it's rather weathered and this isn't. So what happened here? Well, The big problem with this project is it's so darn heavy, you can't use it. It weighs over 40 pounds. Who can use a step stool that weighs over 40 pounds? Can you imagine moving that around the kitchen, or your wife moving it around the kitchen if you're a guy? So obviously it couldn't be used for what it was intended for. And I had looked at it and I said, okay, what am I going to do with this? Well, here's what I did. I cut it in half. This part, my wife has been using outside as a plant stand. That's why it's so weathered looking. This part, I put some bench dog holes in it and a vise on it. And you've probably seen me use this at one time or another in some of my videos where I've got a bench on the bench. Yeah, this is my bench on the bench. It started out as the bottom step of the step stool. And this is really useful because it allows me to bring things up where it's easier to see than in my normal bench vise. So I've used this quite a bit. So what turned out to be a disaster, not because it was poorly executed, but because actually it was poorly designed, has turned into two somethings that are quite useful. And that's making the most of your woodworking.